as the original topic of this presentation was about security in Tizen 3.0, but some time ago I realized that it is so generic that I can give light to all this. So more generic is the light is different enough, but as follows. What I'll be talking about, briefly about security requirements. What is something about Tizen, but as I said, it is so generic that it applies not only to Tizen. Then the main part of the presentation proposed by me and my team security model. Then about lifecycle application in our models. So, about security requirements. This is our reality, our everyday life. We store more and more data on our embedded mobile devices like smartphones, smartwatches. We want it to be secure and private. There is much work done in embedded devices, especially in mobile devices like Android phones, iOS phones, with security, with privileges, and it's not present on our desktop distributions on our desktop systems. For example, here's basically the same application tried to be installed on Ubuntu and on Android. What's the difference? The difference is when we click install, Ubuntu is asking us about our password to authorize the process of installation, but on, for example, this example is Android, but it's common to most of mobile systems. It's asking about privileges granted to the applications. So, when you install on desktop, the run software is acting on behalf of our system. It can do everything we could do sitting at our keyboard, console, and so on. But mobile devices which support privileges, the application is constrained in many different ways. For example, about resources it can touch or not, and so on and so on. There is some conflict because between the granularity of these privileges. For example, if you want to restrict access to contacts, or maybe reading contacts, editing contacts, and so on, and the conflict of the usage and administration of such devices. So, this model was originally designed for Tizen operating system. And talking about Tizen, so we know where it all came from. But as I said at the beginning, it is so generic that it can be applied to every Linux distribution. First of all, Tizen was designed for embedded devices. Mainly smartphones, smartwatches, but it's a normal Linux distribution. It's developed by open source community. At the moment, the main effort, the main input contribution is made by Samsung, but it's open source. You can go on Tizen.org and download all the sources and put on the device of your choice, for example, Android, Raspberry Pi, and so on. This is where you can see the Tizen device in the right. So there are some IBI systems, mobile phones, smartwatches, and more. And everybody can join this instrument security by installing Tizen on their device. There are two Tizens at the moment. Tizen of series 2.x, and it's commercially deployed on many devices, mainly by Samsung. And there is next generation Tizen 3.0, which is still in development. It's, as I said, it's completely open source. It can be run on devices you can go, you can buy in every electronics shop, and it supports our new model, dedicated security model I will talk about now. So, on every operating system, not only embedded, not only mobile, but this is what we think about if we say embedded, but Servicio, Ubuntu, Fedora, any other distribution. You have some services, you have some resources you probably want to protect. This may be email, camera, networking, and many more. What mobile devices especially are proposing is connecting these resources with privileges. So basically the things you can do with these resources or services. For example, if you have email, then you may want to just read them or send emails, maybe preview contacts, camera, networking, so on, so on. But as I said at the beginning, if you install application, for example on Ubuntu, it acts on your behalf to full extent. So if you download a random application from internet, maybe some sort of game or calculator, it can read your emails, it can SSH to your remote hosts if you have your keys on it, and so on. So we have to put some access control. So not every application will have access to our services and resources. This is what is done on most of mobile systems nowadays, but first of all, not all of them, and not so generically that it could be put on desktop distributions. And here is our dedicated model which supports this scenario. It consists of three pillars of security. First of them is discretionary access control. Next is smart. It's one of smart and dedicated user space daemon privilege checker Cenara, which was already mentioned by Jose today, and I will tell you much more about it. But what we use three of the pillars in our security model. First is DAC. As most of you know, if you don't know what is DAC, then you know what is DAC. It's the classic Unix privileges, not privilege, maybe access control system in Unixes from 40 or 50 years ago. Basic types of access is reading, writing, executing resources. The main thing about it is that the owner manages access to the resource. It is used to separate users. Next is SMAC. It's one of LSMs in kernel. Maybe if you don't know what it's maybe something similar, but much much simple. How it works? You can label some resources or even processes in the system with labels and have rules which label can do what on which other labels. In Tizen we have three domain policies. First of the domains is floor, and we put in this domain some system directories. Next system we run in this domain every system services and user directories and user services. And the last one is Tzenara. It's user space privilege checker. It's dedicated for Tizen, but it's generic. It can be compiled and run on any other distribution. It has basically no dependencies. How Tzenara works? Basically, let's say we have some service, for example, GPS, and there is an application which wants to access the location of the device it runs. So it's using some kind of IPC to access the service, and the service should know if the information about location in this example should be granted to the application. But how does it know? So it contacts Tzenara and sends the credentials of the client, its application in this example, to Tzenara, and Tzenara knows the answer. So this application is identified by the service. The credentials are sent to Tzenara, and Tzenara returns what to say to application, if the service should grant access to the location or not. Tzenara has a database which can be queried in order to find the answer, and we can use some extensions, for example pop-ups, to ask user if the access should be granted or not, and so on. How Tzenara knows all these answers? First of all, it has some built-in same defaults. Next, installed applications come with manifest. If you use Android as developers of applications, it may sound familiar to you. Next, privacy manager, which allows to alter the policy on runtime, and so is administrator, because Tizen is multi-user system, so there is a role of administrator which can alter the policy. So, what is the life cycle of the application? First I need to tell you about security manager. It's also user space service which manages all steps in the life cycle of the application. Basically, it helps with installing applications. So the DAG rules, the SMAC rules should be populated by installing application. It applies security context by running application. I will tell more about it in a minute. Managing security policies, for example, reading those manifests of applications, or allowing privacy manager to alter the policy, and it also manages users. So, first step in the life cycle of application is, of course, installation. It's in two parts. First is simply unpacking the file, but it's not a big deal. The next part is secured by a security manager, which reads manifest, so it knows what privileges should be granted to the application. So it can populate scenario database, it can label the files on the file system and create DAC rules, DAC permissions. Next, the launching of application. It's done by a launcher, but it cooperates with security manager and Synara to properly spawn the process, to properly apply the security context to the newly spawned process. So, first of all, it checks what effective groups have to be applied to the process and what SMAC label should be applied to this process. So, how does it work in general? We have, as an example before, some application, for example maps, which wants to know the rotation of the device. So it comes to the GPS and asks about the location. GPS asks Synara and does the answer. How does it look in more details? This is our applications, and the credentials which are identified, identifying the application are first of all user. Next is a SMAC label of the application, and there is also a third part of the privilege, which is bound to the service. So we have maps application, which is, for example, user app maps. We have UID, which is 1001, and we have privilege, which is in this example Tizen org privilege location. This triple is forwarded to Synara. Synara has its database, has its plugins, and can answer the question if the service should provide the answer to the application. This is a demo. You can go to the K building and see it live. We have application in this example contact, which we can edit our contacts. But you can see here that we have the privileges contact read and contact write. First of them is set for allow, and the second one is set to ask you. So, if you want to read the contacts with the application contacts, it can be done. But if you want to edit the contacts, you will be provided with a pop-up asking you if this application, you can see SMAC label of this application here, user app contacts client, run by user identified with this ID and trying to access this privilege. And you can answer this question and let the application to operate or not. My time is up, so I just quickly tell you that there is also another scenario, direct access to the resources, when you don't have any service governing the resource. For example, you have GPS service, but sometimes you have file resources which have to be accessed directly. So there is only one chance to control the access. I mean by launching the application. So the dev camera file system resource is owned by group camera users. So the application, in this example camera, should be in effective group of camera users who have access to this device, and if this applied, this group is applied on the start on spawning the application. We have some bonuses also. If your service is running on device, then you don't have anything to do, just write a proper config file to have DBus protecting your application with cooperation with Synara. There are some other tools for auditing, for networking, access control, and also containers which upgrade security. And this is it. Have you any time for questions?
Yeah, I think we have a couple of minutes. 3 minutes left. So if anyone, thank you, Alexander.
So in order for the scenario system to make sense, you need to, safely identify the application, right? So you need to make sure that the Maps application does not leak its credentials so that other applications can, identify themselves as the Maps application. So I suppose you need a system like SMAC to assign these labels during installation, because otherwise, if you can't safely identify the application, then, you cannot use the system properly, I suppose. So are there any alternatives to the SMAC system to still make use of Synara?
I think so. First of all, you can use other LSM to label the process of the application. I think you can use SE Linux for this. Maybe you could also use C groups maybe. Synara is so generic that it accepts any unique string for the client part of credentials. Here, in Tizen, it's smart label. In a system of your choice, it could be, I don't know, maybe path to the executable binary, maybe C group, maybe Linux label. So it's anything that could identify your application to differentiate it from another one.
Right, yeah, if such a thing exists. How does that compare to, say, Policy Kit?
Policy Kit was it didn't meet our performance needs because it was too slow to manage basically all the security checks in our application. If Policy Kit is meant to provide security checks interacting with portals, but we have almost all API calls managed, checked by Synara. So Policy Kit couldn't do that because it was too slow.
Any more questions? We can have one final question now. Probably. Yes, half a minute.
Hi. My question may be stupid, but if the goal is to take the security model of phones and take it to computers, wouldn't that be too much of a shift in security models for the user to take into account? Wouldn't it be too restrictive for the apps, for example? Wouldn't the user be harassed by all these permissions?
It's hard to answer because it's all up to user. It's up to what user expects from their system. For example, I would want my system to protect my emails, my camera, and so on, just like my phone does. But it's up to user.
Okay, I think time's up. Thank you, Alexander.
Thank you.